Good morning. So today we will continue our discussion on materials for energy storage devices, and we will start a new topic, that is fuel cell. So we have already discussed under this lecture other storage devices like battery, capacitor, supercapacitor, and then lithium ion battery. And now we will discuss the last topic or the last storage device of this series, that is fuel cell. I have already given you an idea that what are the different storage devices in terms of their power density and energy density in the introduction part of this particular lecture series. And then we know that different storage devices play different role in terms of their energy density and power density. Fuel cell is one of these devices in this series of storage devices. Actually, fuel cell is a very simple storage device in terms of its mechanism. It simply works on the principle of electrochemical reaction, where you have hydrogenous fuel and you pump in oxygen and then they react and produces water and heat and electricity. So you can say this is the simplest reaction possible to generate energy. Hydrogen as fuel with oxygen inside the fuel cell, producing water, heat and electricity. And if you look at this entire process, it is very clearly, it tells there is no emission. It is zero emission. So you can say it's zero pollution. And that is the main motivation of working with the fuel cell. And it has invented long back. The process of fuel cell was invented in 1830s or 40s, where people have shown how one can use electrochemical reaction, because it is the simplest reaction. And the conceptual fuel cell was discussed almost 200 years back. And then in 1896 already a design of fuel cell was demonstrated, and practically what you call the modern fuel cell came into existence after 1950s. And then there are many fuel cells which people have worked on, and you will find it in the literature, and I will also discuss a little bit about different fuel cells today. But the question is, what is its role? If you go to a rural area, it is sometimes very difficult, or some places, say in hilly area, or some place where it is very difficult to access, and then make a complete the power system with grid and everything. Sometimes it is difficult. Even if it is done, the adequate power, electrical energy and electrical power cannot be supplied to such places or in a space shuttle. So people are looking for a device, a storage device, which can be used for small scale like portable devices, as well as also for large scale like powering an area of a remote place. And fuel cell is a very good alternative source of energy in that respect. And also it is uninterruptible. One need not charge the fuel cell again and again. So this tells that one can have a device with very easy process, very simple chemistry, based on very simple chemistry, a device which does not create pollution, and a device which can be used for small scale and large scale, where the main motivation of searching for fuel cell. So if we just look at what is fuel cell, very simple, as I mentioned, that I can think about a situation, okay, where I have a structure with anode, cathode and electrolyte in between, and then I pass hydrogen as fuel. So somewhere you have to store hydrogen. This is one requirement, of course, but you send hydrogen as fuel, and then you also flow oxygen gas in the system, and this system does something inside it, very simple reactions, and then what you get is water, heat and electricity. This is what the motivation of designing a fuel cell. Okay, so this simple process, it shows that there is no emission, there is no carbon emission or any other emission which can pollute the the environment. And present days, the kind of devices which you use in car and other the vehicles, they create lot of pollution. We know, although there are a lot of ways people are finding to reduce the pollution, but this is one way. You can think about a car where you can, instead of a battery, you just put a fuel cell inside. So I replace my battery with the fuel cell. What additional I require when I replace battery with fuel cell is some hydrogen storage tank, because this is the fuel for this fuel cell. Okay, this is the only requirement, but we get a zero emission car. This car does not pollute. Okay, so let us see some devices which we have discussed so far, and how they are if we make a comparison in terms of various the parameters, various physical quantities, where do they stand. So the first thing, I talked about one particular fuel cells, direct methanol fuel cell, DMFC. There are many fuel cells, we will see it today, and one fuel cell is direct methanol fuel cell. Depending upon which electrolyte you use, there are different fuel cells. So if you look at suppose we look at different the parameters, like gravimetric energy density, which is in the unit of watt-hour per kilogram, it is more than 1000. Volumetric energy density is in the range of 700 to 1000. Now, power density is 100 to 200 watt per kilogram, and capital cost in dollar per kilowatt hour is around 200. Now, let me compare it with other energy storage devices. Lead acid battery, which we use everywhere, its gravimetric energy is much smaller as compared to fuel cell. Volumetric energy density is also much smaller as compared to fuel cell. Power density is comparable with fuel cell, and capital cost is of course much less as compared to fuel cell. So, this is an important point, of course, the cost of a device. So, therefore, people use lead acid battery, although they know that there are a lot of toxic element present in the lead acid battery, but anyway people are using, and this need to be replaced. Now, we come to nickel cadmium battery. The gravimetric energy density is much smaller as compared to fuel cell. Similarly, volumetric energy density is also much smaller. Power density is comparable. Capital cost is even higher as compared to fuel cell. Okay. Now, we come to nickel metal hydride battery. Gravimetric energy density is small, volumetric energy density is also smaller, power density is slightly higher, capital cost is higher. Lithium ion battery, which we have just discussed before fuel cell, gravimetric energy density is small, volumetric energy density is small, power density is higher as compared to fuel cell, and we have seen it earlier in the introduction section in the Ragoner plot, and capital cost is higher as compared to fuel cell. Coming to flywheel, the gravimetric energy density is smaller, volumetric energy density is smaller, power density is almost same or slightly higher, capital cost is higher. Now, we go to ultra capacitor, which is in other side and which we have already discussed, or supercapacitor. Gravimetric energy density is much smaller, volumetric energy density is also much smaller, power density is very high, and that we mentioned when we discussed supercapacitor. The importance of supercapacitor is that its power density is quite high, but its capital cost is also very high. Okay. So, we see that in terms of all these parameters, fuel cell is in a very comfortable position and can be used in many places, which I just discussed right now. So, you can design a small fuel cell that I have shown. What you need? You need 2 electrodes, 1 anode, 1 cathode, and then 1 fuel supplier from where the hydrogen fuel comes, okay, and then they react inside the fuel cell chamber, all right, and then you get the water and heat along with electricity when you flow oxygen inside that device. So, this is a small structure of a fuel cell. You can make it in the laboratory, very simple chemistry. But when we talk about the delivery of power to different equipments, different transport system, and you know even in the military system, people use fuel cell frequently, or if we think about the large scale uses of fuel cell or in some UPS, then what we need to have many fuel cells stacked together. Okay. So, one such fuel cell you can see here, this is definitely a completely power generator, you can say, which can be constructed out of many fuel cell, which can provide energy to a big residential area. Okay. So, once we have this big fuel cell power generator, and we would like to compare with other power generators which exist now, technology, device, everything exists, and let us see where does it stand. So, let us compare in terms of function. You can see fuel cell, what is its function? Its function is energy conversion. If I compare with the battery, which is very largely circulated devices still now which we use, its function is both energy storage as well as conversion. And if we consider heat engine, which are also being used now, they are also energy converter. Now coming to technology, it's technology, that is what is the basic process which drive these particular devices. For fuel cell, it is electrochemical reactions. For battery, also electrochemical reactions. But for heat engine, it is combustion. Now, if we consider fuel, the typical fuel for fuel cell is usually pure hydrogen. Remember, we already discussed about pure hydrogen in our previous lectures, and we talked about green hydrogen. Okay, one can use this green hydrogen or the hydrogen produced by green process as a fuel to the fuel cell. But for battery, it is stored chemicals, and for heat engine, we all know gasoline, diesel, etc., petrol, etc., which are used for as a fuel. Now, if we look at useful output, for fuel cell, the useful output is DC electricity. For battery is also DC electricity, okay, and for heat engine, it is mechanical power. And we see how this energy gets converted to mechanical power of various devices. So, what are the main advantages of a fuel cell? It is having high efficiency. Even battery is also having high efficiency, but heat engine is having high maturity. Fuel cell has reduced harmful emission, or almost you can say zero emission for fuel cell, and for battery it is high maturity, and for heat engine is low cost. What are the main disadvantages? That is very important. Before we have to make something in technology and spread it for the use of the society. One should know what are the disadvantages. It is having slightly higher cost that I have shown already. Battery is disadvantage that they have low operation cycle, and heat engine significant harmful emission. We all know, we all suffer from this heat engine significant harmful emission. Fuel cell has low durability, battery is also having low durability, and heat engine has low efficiency. So, these are few disadvantages and advantages, and some function and operation of some of the power generators which we generally use in our day-to-day life. Okay. So, again coming back to this point very precisely, that what are the advantages and disadvantages of a fuel cell in particular. The first advantage is that it is having zero emission. So, I already mentioned that fuel cell is an electrochemical device which only produce water, heat and electricity. It does not produce any harmful gases. So, therefore, its emission is practically zero. Okay? And it is having high efficiency that I have already mentioned. Okay? And it is having high energy density, that also I have already mentioned. Quiet operation. Quiet operation means it does not create any noise. Fuel cell is a device. So, if you want to use fuel cell as an electricity supply for a residential area, suppose, where we would always like to have reduced noise or low noise, fuel cell is a very good choice. Okay? And no recharge. This is a very important thing. You do not have to recharge. Other devices, we know, other batteries and other things we need to recharge, but for fuel cell you do not have to recharge. Okay? And there are certain disadvantages. One is the hydrogen storage. You need to store hydrogen. There is a very important, not disadvantages I will say, but it is a technologically it is a challenge to store hydrogen, although people are going towards that technology, that how to store hydrogen in large quantity, and its cost, and of course, as I mentioned, its durability. So, these are certain disadvantages, but there are a lot of advantages of fuel cell to be used for practical purpose. Okay. So, now let us look at what is the configuration of a fuel cell. So, I already told you that fuel cell basically is a device which consists of two electrodes, very simple. Anode cathode and then you have kind of electrolyte, or you can say membrane. And you put it in a container. Okay. What we need to do here, we have to pass hydrogen towards the anode side and oxygen towards the cathode side. Okay. So, when hydrogen goes to anode, it splits up in hydrogen plus and electron. So, if I make it 2, then I have all 2 electrons. Okay. So, what happened? These H plus and E minus are produced. The electrolyte or the membrane is designed in such a manner in a fuel cell that it does not allow electron to pass in this direction. Okay. Only H plus flows in this direction. Okay. And then electron, it goes out in another direction, it goes towards an outside circuit. Suppose I put a bulb here, it generates electricity, the bulb glows, and then electron comes to cathode, it reacts with oxygen and gives water plus heat. So, you get electricity here, you get H2O and heat in this reaction. One need to balance this reaction. Okay. It's very simple mechanism. Only what we need an anode, an electrolyte and cathode. Okay. And then we produce electricity, heat and water. All right. So, you can look at it very simple, the mechanism which is shown in this animation. So, you can see hydrogen from tank, it is coming, proton exchange membrane, this is one typical membrane, and then you can see this, it splits up into H plus and electron goes towards this direction, the bulb glows, that means electricity is generated, and then H plus comes in this way. Okay. So, this is all about the working principle of a fuel cell. But I would like to, before I go to different fuel cell, I would just like to compare the fuel cell energy generator with other energy generators those that exist. So, I just look at different parameters. So, you can see the capacity range of a diesel engine, it is 500 kilowatt to 50 megawatt. If we think about turbine generator, which you see that people are using everywhere, the main source of energy generation process 500 kilowatt to 5 megawatt. Photovoltaic, which we have discussed in our first module, is 1 kilowatt to 1 megawatt power. Wind turbine is another source of energy. You can see in many places there are wind turbines. It also produces an energy range of 10 kilowatt to 1 megawatt, and fuel cell also produces significant power, 200 kilowatt to 2 megawatt power. So, it can really compete with these energy generators. In terms of efficiency, if we look at the diesel engine is 35%, turbine generator is 29 to 42%. Photovoltaic efficiency, we know that it is always less, although people have predicted photovoltaic efficiency, higher efficiency and tandem photovoltaic devices that I have discussed. But when we look at the practical photovoltaics which we use for our the different commercial purpose or for the energy generation, the efficiency is quite low, 6 to 19%. Wind turbine has slightly higher efficiency, but in terms of efficiency, fuel cell is very high, 40 to 85% efficiency, depending upon which fuel cell we are considering, which I will show after this. Okay. So, this is one thing which you have to remember, that when we are struggling so much with the efficiency of photovoltaics, we are through in terms of efficiency as far as fuel cell is concerned. It is highly efficient. Capital cost is 200 to 350. I have already discussed. Turbine generator is slightly higher, photovoltaics is very high, wind turbine is also high, and fuel cell is also in the higher side. And then O&M cost, these are other technical parameters. You can say they are more or less comparable. Okay. So, fine. So, we get a good idea, fairly good idea about where fuel cell stands at this moment in terms of energy generators and how it is compared with different energy generation process and devices. Okay. Now, I will come to different fuel cells. What are different fuel cells that people have made so far, and some of them are are working in such a way that people use it in a very different environment like in space. So, let us first look at the alkaline fuel cell. What is alkaline fuel cell? So, as I just now I discussed, the basic idea of fuel cell is always same. The fuel should be hydrogen or any hydrogen compound. The main fuel is hydrogen. So, you have to pass hydrogen and it goes through anode. Okay. So, it is the same way which just now I have shown you, the electron flows in this direction. Okay. After it splits into H plus and OH minus, and then H plus and electron, sorry, not OH minus, and then oxygen flows in this direction, electron comes in this direction. So, we have oxidation process where OH minus or hydroxyl ion, which is actually generated in this electrolyte because it is an alkaline electrolyte. So, let me again tell you that when we make different fuel cell, the difference only comes in the electrolyte. Okay. So, alkaline fuel cell means I have an alkaline compound as an electrolyte. Okay. So, it gives OH minus. So, oxidation takes place where hydrogen reacts with OH minus, produce water. You can see that water goes in this direction and then it produces electron. And the reduction which takes place here where oxygen reacts with water and electron and produces 4OH minus. Okay. So, if we look at the operation or operating temperature for this fuel cell, it is 60 to 90 degrees centigrade. These are typical numbers which I am telling. It may vary, and with the research people also shown variation from these typical parameters. Electrical efficiency is of the order of 70%, which is quite high, and then electricity generation is up to 20 kilowatt, which is also reasonably high. And then as I told you that where you can use fuel cell, this particular fuel cell AFC, people have used, NASA has used actually in the space shuttle for the different provide water and electricity in the space shuttle, and this small fuel cell was used for that, and there are many other fuel cells which are used for different purposes, and I will come to this point just little later. And now we look at another fuel cell, okay, that is called phosphoric acid fuel cell. And as I mentioned that when we design a fuel cell, the main idea is to change the electrolyte. So, now you have an electrolyte which actually contains a phosphoric acid. Okay. Otherwise, the reactions look almost same. So, you have hydrogen is input, electron goes in this direction producing electricity, and oxygen is the input towards the cathode. Okay. And then the reactions are slightly different as compared to AFC. Here the oxidation where H2 splits into H plus and E minus. Okay. So, H plus goes and it reacts with oxygen, all right, at cathode, and it produces water which comes out, and of course, it produces heat, and then you also get as H2 as output gas. Okay. So, it is slightly different depending upon which electrolyte you are using, but its operating temperature is higher as compared to AFC, all right, and its efficiency is of the order of 40 to 80%, which is comparable to AFC, and in some cases it is slightly higher, but its the electricity generation is quite high. It is of the range of 200 kilowatt. In some cases, people have also shown its uses in very high power like 10 to 11 megawatt. Now, we come to third category of fuel cell, which is solid oxide fuel cell, and as I mentioned that you need to change the electrolyte when you design a fuel cell, and now you change the electrolyte to a solid. Okay. What solid people use as electrolyte in SOFC, solid oxide fuel cell, it is YSZ, yttria stabilized zirconia. This is the standard. The solid which is used in SOFC or solid oxide fuel cell. But mechanism is almost same. This hydrogen is flowing here, it is splitting into electron and H plus, okay, and then you have oxidation reaction where oxygen reacts with this electron, produces O2 minus because it is a solid electrolyte, and the reduction reaction is O2 minus reacts with hydrogen gas, produces water, and also it produces electron which flows through the circuit and it produces electricity. So, H2O comes out in this direction, and any the axis here it comes out as an output in this direction. Okay. So, now the fourth one, which is molten carbonate fuel cell, we have a carbonate compound, molten carbonate compound as electrolyte, and rest other processes are same. Hydrogen goes in this direction, oxygen in this direction, okay, and this reaction takes place. Hydrogen reacts with a carbonate ion, it produces H2O, CO2 and electron, and then oxygen which is flowing towards the cathode, it reacts with carbon dioxide and electron and produces carbonate ion. Okay. And what is the typical operating temperature? It is quite high. Efficiency is also quite high, 60 to 80% efficiency, and electricity generation is also higher, almost in the megawatt range. Okay. And proton exchange membrane fuel cell, which is a very popular fuel cell, PEMFC people use in many places. It is very simple working device. So, you can see that the membrane you change, that is called proton exchange membrane, which we discussed as a basic fuel cell. This is the principle of that. So, this is the electrolyte, and hydrogen flows in this direction, oxygen flows in this direction towards the cathode, and then hydrogen splits up in H plus and E minus goes in this direction, produces electricity and coming back to the cathode. So, the reaction is the splitting of hydrogen in H plus and E minus, and then cathode the oxygen gas reacts with H plus and E minus producing water as output, and then overall reaction if you look at it is H2 and O2 reacts and make H2O heat and electricity is generated. Okay. Its operating temperature is also moderate, around 80 degrees centigrade, electrical efficiency is slightly less, 40 to 50%, okay, electrical efficiency, and electricity generation, power generation capacity is also little less, 50 to 250 kilowatt, okay. So, there is another fuel cell called DMFC, which I mentioned initially, but I am not going to discuss it in detail. When you know, the direct methanol fuel cell, where methanol is used as electrolyte, but one can find it in the literature. Now, I come to applications. This is very important, that where do you apply and what feature you look for. Suppose you are going to design a fuel cell tomorrow, or you want to make a fuel cell generator, then it is extremely important that you should know what feature is there and it is for what purpose, what application. So, let me first tell about the what feature we look for and what application we get. Okay. So, when we look for a feature like high and consistent efficiency, so I already mentioned that fuel cell efficiency is very high, then one can use it in propulsion system, one can use it in light traction vehicle, one can use it in auxiliary power units, one can use it in distributed generation. Second feature, if we have reduced or eliminated harmful emissions, we look for, then our application areas are again propulsion system, light traction vehicles, auxiliary power units, distributed generation. Suppose we look for a feature with long operational cycle, okay, then its application area is portable application, propulsion system, light traction vehicles, and emergency backup. Now, if we consider for higher energy density feature, then we can have it in the portable application, propulsion system, light traction vehicles, and emergency backup. If we look for prompt load following, then we can use it for propulsion system, light traction vehicle, auxiliary power units, distributed generation. Okay. Modularity, we can use it for portable application, auxiliary power units, distributed generation. Okay. Then reduced or eliminated noise, we can use for propulsion system, light traction vehicles, auxiliary power units, and distributed generation. And if we look for fuel flexibility, then we can use it for portable application, distributed generation, and emergency backup. Okay. And if we look for a feature like high integrability with renewable sources, okay, then we can get an application in propulsion system, distributed generation. Okay, so this gives a broad idea about what are the application areas of different fuel cell with different feature. Okay. So, let me now summarize what we have discussed in the today's lecture. I discussed about the basics of fuel cell, the motivation to do research in fuel cell, and what are the importance of the fuel cell. Then I also talked about what are the advantages and disadvantages of fuel cell. I also made a comparison of fuel cell with other energy storage devices. Okay. And then what is the construction of a fuel cell and what is the working principle of a typical fuel cell. And then I discussed about different fuel cell configuration depending upon which electrolyte you are using, like AFC, PAFC, SOFC, MCFC, PMFC. Okay. And then we discussed what are the typical application of fuel cells depending upon which feature we want to look at and what are the application areas of the fuel cells. Thank you.